Hi there, today I'll be walking you through the SCANOSS ORT integration. So what is ORT? ORT is a command line tool that brings everything into one place, from generating SBOMs and scanning for security vulnerabilities to analyzing licenses and producing clear consolidated reports. ORT has 5 stages. The analyzer stage, which reads the dependency manifests, builds the dependency tree, logs the repository URL and outputs the analyzer results.json file. It has the scanner, which clones the repository, sends the source files to SCANOSS for fingerprinting, and returns component information. It has the advisor, which checks for vulnerabilities using configured services, the evaluator, which enforces custom compliance rules via ORT's policies engine, and the reporter, which generates reports in formats such as SPDX, CycloneDX, or HTML. In terms of prerequisites and installation, there's a few things that you need. First, you need a SCANOSS API key if you're looking to use the enterprise features. Next, your project should live in a repository under some sort of version control so that it can be cloned. And finally, if you're building ORT from sources, you'll need the Java Development Kit version 25 or later. For installation, you have 3 options. Build from source, use the Docker image, or run the pre-built binaries. These all work on Linux, Mac, and Windows. To configure ORT with SCANOSS, you first have to create a config.yml file in your .ort folder and set the API URL and key. Alternatively, you can scan against the public OSS KB without an API key. To walk you through the core ORT workflow, first the analyzer reads the project. Next, the scan fingerprints the source with SCANOSS. And finally, the report generates outputs in various formats. So looking at the iterative workflow, this is how you would use ORT and SCANOSS in practice. First, you run the ORT analyze to generate analyser results.yml. Then you run ORT scan to produce scan results with all findings, matches, licenses, and snippets. And then you review the results, make decisions on what's valid, false positives, or what should be excluded. Record these decisions in your .ort.yml file as your source of truth, and then rerun the analyze and the scan with those decisions applied. To show you how this works in practice, I'll first have to download ORT, and I'm doing this by this curl command right here. Once that's successfully done, I then need to extract it by running the following command. Then I need to ensure that I have the relevant prerequisites installed, so in this case is the JDK version 25. Then once that's done, I have to extract it as well. I then would tell Linux to use this Java version, and then this also puts the Java binaries at the beginning of your path. I'll then clone a sample GitHub project to actually run the scan on. So I'm cloning this lodash repository right here. And then I'll go ahead and point to the ORT executable. As mentioned previously, you have to edit the ort config.yml file to configure SCANOSS. You can include the following parameters to configure your SCANOSS API key. So mention the scanner, SCANOSS, API URL, and for secrets, mention your API key. So then I'll go ahead and run ort analyze to actually analyze the project itself. Once the analyzer is done, you can then look into the analyzer results by going into cd analyzer out and then looking at the analyzer results.json file. As mentioned previously, the analyzer stage reads the dependency manifests, builds the dependency tree, logs the repository details, and outputs the analyzer results.json file. Once you've taken a look at the analyzer results, you can then go back and then run the ORT scan with the following command. ORT scan, mention the analyzer results.json file, mention SCANOSS for the scanner, mention the output folder and the format of the file that you want to output. So in this case, it's JSON. As you can see, the scan has started mentioning the ORT Toolkit version 9.1.0, and then mentioning that it's scanning the projects with SCANOSS version 5.4.25. Once that's done, you can then go into scan out and then do an ls, and you can see a scan results.json file has been created. So then you can cat the scan.json to actually observe the results for the following project after the scan is complete. So starting at the top, we have the repository block. This tells us what's scanned and where it came from. Scrolling down to the analyzer block, this is the metadata about the first stage, so any dependency analysis, and we can see when the analyzer ran, so the start and end time. Continuing down to the scanner block, now we're into the actual SCANOSS run. So same shape as beforehand, the start and end time, the environment. Then in terms of the configuration, we can see that the scanner is SCANOSS and it's pointing to api.scanoss.com. And then we can see the ignore patterns that it used right here. Then we can scroll down to the scan results, and inside it there's one entry per file that SCANOSS has matched. So we have here the source location for the actual file that's in our repo that we scanned, the match came back with a score of 100%, meaning it's a full file match. And if we scroll down, we have the relevant Perl, the license, the additional metadata, which includes the vendor version, latest file hash, file URL, the release date, and so on. And then we can observe the same kind of details for the rest of the matches that SCANOSS has actually scanned. Going through all the files that SCANOSS has scanned, you can actually confirm this by also scrolling down to the very bottom. And this is the whole file list. So this is just the complete inventory of every file that SCANOSS has actually looked at. Now, to make decisions on the actual scan results that you've observed, you have to actually create a .ort.yml file in the project repository that you scanned. So running nano, mentioning the project folder, .ort.yml. I already have one created, which excludes the relevant scopes. Now, to show you how to include and discard some of the snippets that it found, you can include the following blocks. Snippet choices, mention the provenance. For the choices, mention the source location, so the path, the start and end line. Mention the relevant Perl. I'm saying that it's an original finding, so I'm saying that I'm accepting it as my own lodash source for this demo. And then for the second option right here, I'm mentioning the path again, start and end line, and I'm saying that it's a non-relevant finding, so I'm disregarding this match for the demo here as well. Now, this is just an example. Then you would go ahead and save this file. Now that we've created that .ort.yml file, we have to run the ort analyse command and the ort scan command again to ensure that these settings are considered in the future scans. And that's how you would use ort and SCANOSS in practice. So you run the ort analyzer to generate the analyzer results, then you run the ort scan to produce the scan results with all findings, review the results, make the decisions by declaring the .ort.yml file. So make decisions in terms of what's valid, what's false positive, what should be excluded, record these, rerun the analyze command, rerun the ort scan command, and then generate the report in your valid format. So HTML, Cyclone DX, and then SPDX. Thank you so much for watching.